Hello, my name is Sukruth Ganesh. Welcome to the recording of my intermediate Python final project at the University of Chicago. My project deals with finding the optimal path for given a source and a destination, and given the number of containers we have to transport within a given time. I'm using this data set in the model data file, which has four locations, four major cities: Singapore, Shanghai, Malaysia, and Wuxi. And each city has a port, airport, railway station, and a warehouse. So let's take this row for example. Here we are going to transport goods from Singapore port to Shanghai port. The capacity of that route is 67 containers. So 67 containers can be transported in one go. And the travel mode is sea. The cost associated with the transport is this, and we have certain transit duty with it. And also this the time required to transport the goods. Coming to the storage information, we have the storage cost per hour per container for each of these locations. Let me run this program quickly. It's asking me for the source. Let me enter some random text so that I can show it. It has some certain user validations that run in the background. So if I enter the correct source that is present in the dataset, it will accept that. Let me enter the destination as Malaysia warehouse. The number of containers to be transported as 200, and the hours within which the delivery should be done as 4000. So what this does is it creates three new files: bestroot.txt, network.png, and optimalpath.png. Let me open network.png. So this is a graph of all the locations and the edges between them. As you can see, this tuple denotes the edge weight. So the first value denotes the total cost to travel from Shanghai warehouse to Shanghai port. The second value denotes the time taken, and the third is the capacity. And each edge is colored. The green color stands for a truck route, blue color stands for a sea route, the maroon color stands for railway route, and the red color stands for the air route. Okay. And it also generates an optimal path file which has all the nodes, but it only shows the optimal path between the source and destination. Here the source is Singapore warehouse and destination is Malaysia warehouse. So the optimal path would be going from Singapore warehouse to Singapore port, then to Malaysia port, and then finally to Malaysia warehouse. Uh, in the best route file, we have a detailed breakdown of what is happening at each step. So at the beginning, the containers were transported from Singapore warehouse to Singapore port. So the number of containers that were transported is 34. So as you can see, Singapore warehouse has been updated to 166 containers, and Singapore port has 34 containers. The storage cost is this much, since we are going to store 166 containers for the duration of the transport, like transport from Singapore warehouse to Singapore port. The money spent would be 1000 and time spent would be 54 hours. And at each step, we are showing the total money spent till now and the total time taken till now. Post this, the vehicle comes back from Singapore warehouse to Singapore port. This time, it is not going to transport any containers. But since we are storing this 166 containers at Singapore warehouse for this duration, the storage cost will add up to the total money spent. And finally, after transporting all the containers to a destination, we get the most cost effective path and the total time, total money and time spent. Let me walk you through the code. In this project, I'm using networkx as the main library to plot to implement graphs, and I'm using matplotlib to plot the graphs, and pandas to read data from an Excel file. So in the beginning, I'm just reading the root data from the root information sheet in the model data file, and the storage data from the storage information sheet in the model data file as well. So at the beginning, it executes the main function. In the main function, we are asking for user inputs. We are asking for the source, destination, the number of containers to be transported, and the time within which these containers must be transported to a destination. And each input has certain validations. So if we enter an invalid input, it will again ask you for that value. Mm, And finally, after all the inputs are done, we'll call the create graph method. In create graph, we'll be creating a directional graph, the one with arrows, and we'll loop through all the routes in the network. So the starting location will be obtained from the column starting location in the dataset. The ending location will also be obtained similarly, and then we'll be adding all these nodes to the graph. Post that, we'll be assigning a color to each edge based on the travel mode, and then we'll also calculate the total cost for that route by adding all of these costs shown here. And finally, we'll be multiplying that cost with the transit duty to obtain the total cost. And similarly, we'll also calculate the total time taken by adding all of these times. And the capacity will be provided by the number of containers, the value under the number of containers column. So here, as you can notice, we are providing the radians value for the edges. So if we provide the value 0, that means we are displaying it as a straight line in the graph. And when we are providing 0.25, it means we are curving the edge. So in networkx, the limitation is that when we show multiple edges from a source to a destination, the edges overlap each other. So we can only see the topmost edge and the its associated edge label. To work around this, I have taken code from the internet to display curved edge labels, and this code is under the curved edge labels Python file. After all this, we'll add the edge with all the attributes, and we'll also find the optimal path by calling the find optimal path method from the optimal path finder file. So what this does is it creates a bestroot.txt file if it's not already there, and in like prints the user input at the beginning of the file. Then it loops through all the paths between the source and destination. To do this, I have used the all simple paths function. The initialize data method is then called. So here what we are doing is like we are initializing the path data, that is the cost, time, and capacity, and also the storage cost from the root data and storage data for a given path. It also creates the container dictionary that stores the number of containers at each node for a given path, and we are returning this information as a tuple. Once we get that, we'll also call the calculate parameters method. So this method calculates the total money and time spent for transferring all the containers from the source to the destination using the given path. So how it does this is like it's going to check whether the destination has the total number of containers that we want to move. Until that, there's a while loop running, and at each step we are going to run a for loop for all the nodes in the path. And if the starting location is equal to path of x, that means like okay, that means we are going from the starting location to the ending location. Else it may be such that starting location is we may be returning from the from one node to the other node. So in that case, starting location would be in path of x plus 1 and the ending location would be path of x. Um, and number of containers to move is obtained by finding the minimum of containers present in the starting point and the edge route and the number of containers that is the capacity of that route. Post that, we are going to update the containers dictionary by transferring the containers from the starting point to the ending point. And then we are going to also calculate the money and time spent during this travel. And the storage information is going to be stored in the storage row info dictionary. So there are two cases now. If the containers dictionary of path of x is 0, that means we don't have any containers at the starting point. In this case, we won't be the vehicle won't be returning to the starting point, and hence we just print the edge info to the best route file. Else, if the containers at the starting point is not equal to 0, the vehicle has to come back to the starting point. So there'll be a storage cost associated with this because we are storing those containers at the starting point. That would be calculated as so, and this would be added to the total money spent, and we are printing this information. Then in the return, we are calculating the return time. This is just adding the custom clearance time and the transit time, since these are the only two time data that is required for returning. And the storage cost is also calculated. And the money is calculated based on only the fuel or bunker cost, since this is the only cost that we need to add when the vehicle is going to return. And then we are finally printing this information onto the best route file. Um, yeah. So once all of this is done, this is going to return the best path. This method is going to return the best path, and then in the main file, we will draw this graph of the optimal path. For that, we first create the graph by taking the whole graph of the network and removing the edges that are not present in the path, and then using the same draw graph function to create the graph. So basically what this does is it creates a figure of size 50 cross 50, and then if the file name is optimal path, then it colors the source as orange and the destination as magenta, and then it draws all the nodes. Post that, it's going to store the edges with data equal to true. What this does is it also takes into account the edge parameters attributes. If we did not mention this here, it would only consider the source and the destination in an edge. And then I'm storing the curved edges. So the way I identify these edges are based on the radiance value. If this is not equal to 0, that means it's a curved edge. If it's equal to 0, it's a straight edge. And suppose that I'm drawing the network edges. So if the file name is network, that means we are going to have a directed graph. So arrows parameter has to be true, and the edge color is obtained by the color parameter in the edge attributes. If the file name is not network, that means it's going to be optimal path. So the arrows would be false. Since we are not going to show arrows, since there'll be a lot of back and forth motion between two nodes, and all of this back and forth motion happens concurrently, but we are going to analyze it sequentially, since Analyzing it sequentially does not affect the total money spent and the total time spent. Um, and after that, what I'm going to do is, if the file name is network, then I'm drawing the curved edges with their labels. Else, I'm going to draw the straight edges, and these are the legends that are going to be shown on the graph. And then finally, these images will be saved as the network.png and optimalpath.png files. So that would be the total walkthrough of my project. Thanks for watching.